Hello everyone, welcome back to this lesson. So our today's lesson is based on trigonometric functions. Um, this is not revision. Now this is the actual lesson where I'll be introducing the graphs, the trigonometric graphs. So let us not waste time. Let me just jump to it. Let's indulge together. So trigonometric functions, when we think of the term trigonometry. Obviously, this comes to your mind. Sine x, cos x, as well as tan x. I believe that, guys, at this stage, especially the grade 10s, you guys are familiar to these three things. Sine, cos, and tan, right? So now, in this lesson, I'll be explaining how to draw the graph of sine, cos, and tan, right? So now let's start with the graph of sine. Let's start with the graph of sine. Let's start with the graph of sine. So before we even draw the graph of sine, normally when they say draw the graph, right? Obviously they expect you to draw a graph in a Cartesian plane, right? Where you have your x and your y values, and then your zero at the origin, right? So usually on x-axis, you end up having 1, 2, 3, and then -1, -2, and then you have your 1 and your 2, -1, and then -2, right? Usually that's what we actually have, right? But then now, when it comes to sine graph, cos graph, tan graph, that's trigonometry, right? We don't have normal numbers per se, but now we use the degrees. So you'll end up finding maybe 90, 180, 270 there, 360, and so forth. It depends on the teacher. If maybe they want you to draw a graph which can continue to 720 and so forth, right? But for grade 10, we only um, restrict you to 360 degrees for grade 10s. And then you have your minus 360 there, right? So basically, on your x-axis, you will have your degrees on your x-axis. So now, the sine graph will take this shape, but it will continue. It will continue forever and ever and ever and ever and ever and ever, right? It won't stop unless the teacher, maybe they start to give you the restriction to say, okay, I want your graph maybe to start at this point and stop at this point, right? Now let's introduce the restriction. Let's introduce the restriction. Now we are saying draw the sine graph. We're drawing the sine graph. Now it needs to start where? This is the restriction. X is an element of, it needs to start at -360 and then stops at 360. Right? We need to draw that graph. So how do we go about drawing this graph? You can just use your calculator. Um, you can start with your -360. So obviously you need to say sine -360, and then you get your value. And you will get your value as 0. So the value here, you will have a 0. And then we continue. Sine negative 270. You get your positive 1 there. And then that becomes a what? A pattern. Becomes a pattern now. So 180, 0. That's sine negative 180. We get a 0. And then sine negative 90. That's negative 1. Sine 0. It's just 0. So you have a point of 0 and 0. And then sine 90. That's 1. And then sine 180. Sine 270. That's negative 1. And then sine 360. That's 0. Now the only thing that is left here is for us to join the points. So now we need to join the points. We're joining our points now. So this is the standard shape of a sine graph, right? Where you have your y equals to sine x. This is the standard graph of sine graph. So now, after drawing the graph, there are things that you need to consider. Firstly, you must consider your domain. Let's start with domain. I believe that you guys are familiar with the domain from the graphs, hyperbola, parabola, straight line, and exponential, right? So what is domain? So for domain, we are saying, where do you see your graph in terms of x? You see our graph from where? Negative 360 to what? To positive 360. So basically, this is our domain. So you'll have your x is an element of negative 360 is to 360. That's the domain. Now, let's talk about the range. Where do you see your graph in terms of y, right? Okay, let me do this. Where do you see your graph in terms of y? So we can say y is an element of negative 1 is to 1. That's where we see our graph in terms of y. And then now the period, let's talk about the period. So now when we talk about the period, the period is just the horizontal distance to complete one cycle. It's just the horizontal distance to complete one cycle. So from here, okay, let me do this. From here, this point, all the way to 360. That's just one cycle to complete the what? Um, One complete wave, actually, right? So now the period becomes 360. So the standard period of sine is 360. The standard period of sine is 360. Now let's move to the amplitude. What is the amplitude of this graph? So the amplitude of this graph is 1. But now how do we get the amplitude? It's just the number in front of your graph, which is 1. Y is equals to sine x, right? So normally you'll have something like this. Y is equals to a sine x. So this value in front of sine x becomes your amplitude, right? But there's another formula to get your amplitude, which is what? A is equals to maximum minus the minimum divided by 2. So let's use these values. So the maximum value here is positive 1 minus negative 1 and then divide by 2. And then you'll get 1 plus 1 divided by 2, which is equals to 2 over 2, which is equals to 1. And then you go to amplitude. It's proven. So your amplitude is just 1. I believe that we are still following. I believe that we are still following. So that's how we draw our graph of sine, right? Now let's draw the graph of cos x. Let's draw the graph of cos x. So guys, I'm still introducing these graphs, né? I'm still introducing these graphs. So drawing the graph of cos x. Number 2. Now they're saying sketch the graph of y equals to cos x. The restriction, x is an element of, again, negative 360 is to 360. Okay. Yeah, the period of this graph, the standard period, is equals to 360. Again, I will explain, right? I'll explain at the later stage. But the definition, we know that period is just the horizontal distance to complete one cycle, right? Perfect. And then from there, now we have to draw the graph. So we need to have the Cartesian plane. That's the first thing. Let's have our Cartesian plane. This is your 0. Start with 90, 180, 270, 360 degrees, x and y. So you have your 1 there and your negative 1. This is negative 90, negative 180, negative 270, and negative 360. Again, we apply the same thing. Cos negative 360, we use a calculator, né? And you get a positive 1 as your y value. So which means your point will be somewhere there. That's the first point, right? Cos 270, you get what? A 0 as your y value. So which means now you'll have your point there. And then we follow the same pattern. Now cos negative 180, that's negative 1. And then cos negative 90, that's 0. And then cos 0, that's positive 1. And then cos 90, 0. Cos 180, it's 1. And then cos 270, 0. Cos 360, that is 0. Right? Now, the only thing that we're left with now is to just join the points. So we just need to join the points. We're joining the points to draw our cos graph. Right? So this is our cos graph. So this is the standard graph of cos. So again, even the cos graph, it can continue like this. It can continue like this without even stopping. It can continue and continue and continue without even stopping. This is the only thing that restricts the graph, which is what? The restriction. So they will give you the restriction before you draw your graph. So before you draw your graph, you check the question. If you are given the restriction, then you draw the graph according to the restriction. Now, after drawing the graph, you must obviously have your what? Your period, which is 360. That's the cos graph. First thing, your domain, D for the domain. What is the domain? This is our domain. Why am I saying that? Where do you see your graph in terms of x? X is an element of negative 360 is to 360. Now, the range, where do you see your graph in terms of y? From negative 1 to positive 1. So you have your negative 1 is to positive 1. Now, the amplitude, A for amplitude, there's 1 there. So your A is equals to 1. So after drawing your graph, you need to have this information, right? So that you'll be able to actually answer the follow-up questions, because they might even say, what is the period of the graph? What is the domain of the graph? What is the range of the graph? What is the amplitude as well? Then it will be easier for you to answer those questions. I believe that we are clear on that one. Now let's move to the last graph, which is our tan graph. This one is quite interesting, but I'll try to make it simpler for us. So tan graph, okay, you have your y, so this is graph number 3. Y is equals to tan x. Again, let's restrict. X is an element of negative 360 is to 360. We are restricted, right? Okay, we have to draw a graph. We need to first start with our Cartesian plane. We label the axis. So it's important for you guys to label the axis. You must label the axis because there's marks for labeling the axis whenever you draw a graph. And then you have your 0 there, right? Now let's use the step of 90. One would use the step of 45, and one would prefer to use the step of 90, right? The shape of the graph will not change. It will not change, right? It will not change. Eish, that's a bit messy. Let me try and fix that part. As I was saying, the shape will not change. One with 45 will maybe shrink a bit, and then the one with 90 will spread a bit, right? So you have your minus 270 there, and then your minus 360. Okay, so for us to draw the tan graph, then obviously we need to say tan 300, tan negative 360. That's just a 0. So you'll have a 0 there, right? But you know what? Let me just start with values minus 270, minus 90, 90, and 270. So for these values, before I explain the story about these values, guys, do you still remember the functions? Hyperbola. When we draw the graph of a hyperbola. So when we draw the graph of hyperbola, usually when we draw the graph of hyperbola, they normally give you maybe a graph with asymptotes. They give you maybe asymptote, where they will say, okay, you will have your graph there, your curves, right? Maybe this is -2, and then this is 4, right? So these values here, they become your what? Your asymptotes. They become your asymptotes. So we apply the same logic to trig graph. Sorry, to a tan graph. We apply the same logic, the logic of asymptotes. Now, how do we do that? So on your calculator, just punch uh, tan negative 270 for me. And then tan negative 90. Yeah, I believe that maybe you got maybe an error, right? I believe that you got an error. So, which simply means where there's an error, then which means that's our what? Asymptote. If there's an error, then we must know that there's a what? An asymptote, which means the graph will never cut or touch those points. Believe that it's clear. So at negative 270, the graph will never touch or cut negative 90, 90, and 270. Those are what? Our asymptotes. And then before drawing the graph, you need to check the sign of tan. So the sign of tan is positive. So since the sign of tan is positive, which means now the graph will start by increasing. It will start by increasing. So now at this value, tan negative 360, that's 0. Tan 180, that's 0. Tan 0 is a 0. And then tan 180 is 0. And then tan 360 is 0 again. Right? But in those values, there's something. There is something that is happening. What is that? Now, here's the thing. Our graph is positive, which means it needs to what? To increase, right? But how do we do that? The arrow will go up. Tan graph. That's the first thing. Because of the positive sign here, then which means our graph will go up, right? And then alternatively, changes, now it decreases and then goes up again, right? Where at zeros. Zero number 1, number 2, number 3, number 4, number 5, right? Sharp. And then even here, you will have your what? Your arrow decreasing, right? And then it changes, goes up now. Perfect. And then down, up, and then down. Now, if you can check the pattern of the graph, you will realize that, or you will rather notice that the graph is actually having this kind of a direction. The graph is increasing. The graph is increasing. Basically, the graph is what? Is increasing, right? Because of the positive sign in front of tan x. So guys, that's how you draw the graph of cos, the graph of sine, and the graph of tan. I will come back with another lesson where I will be explaining where there's a negative tan, negative cos, and negative sine. And then maybe we'll also go maybe, and I will also explain further the effects of an amplitude, the effects of Q, and so forth. So yeah, our today's lesson will stop here. Thank you for watching. Bye.